So today we're going to talk about dividing polynomials, but we're going to talk about it with a remainder. So I've already started recording, guys, so I need you to start being quiet. There should be pencils down. Nobody has to be doing anything. Your yellow folders should be in the middle of your table groups. Okay, so 19 divided by 4. We want to put 19 into 4 groups. When we put 19 into 4 groups, we get 4 in each group with 3 remainder. So I could actually write it as 19 is equal to 4 groups of 4 plus 3 remaining. That's how we've been writing it with our polynomials, right? We've been saying 19 is equal to these 2 factors, but then we've got 3 left over. Another way to write it, as you saw it in elementary school, would be 4, right? 4 goes into 19. 4 goes into 19 4 times. I'm going to put over here. At first you saw it, I think, in probably 3rd grade as our remainder of 3, right? You saw it that way. Another way you could have written it, take this. Oh, my whole picture is going to move. Okay, another way you could have seen it would have been, take this, and put this over here. Another way you could have seen it was 4 with 3 out of 4 remaining, right? 3 out of 4 remaining. Okay, so this can be written this way too with our polynomials. And I'm going to show you how. I'm going to show you all. I'm not going to show you this way, but I'm going to show you this way, and this way. Okay, so the next one too is you should be able to divide polynomials with missing degrees as well. We're going to add that in there today. Okay. So this is a problem that's been done for us, and it has a remainder of negative 25x plus 9. So I can say that this whole, let's see, I think I'll make it blue. This whole dividend right here, right? When it's divided by the divisor, you get the quotient. So this is how I could write this. I'm being a little bit apprehensive because I'm not sure. Yeah, I'll just show you. Okay, 2 ways that you can write this. You can write it, I need you guys to stop whispering back there, please. So I can write it as x squared minus 3x plus 5 times 3x squared plus 4x minus 3 with a remainder of negative 25x plus 9. I can say that this whole thing right here is equal to this multiplied by this with this remaining. Okay, this is the only new part today that I'm showing you. This we did yesterday. Another way to write it, and the only reason I'm showing, this is how I want you to write it. But another way you can possibly see it would be like this. Because some books are going to be different, some programs are going to be different, and I want you to be able to recognize it when you see it, okay? So I could have written it like this. If I have a remainder of something, then this would be my answer, right? And my remainder would be negative, so we'd say plus negative 25x plus 9 all over x squared minus 3x plus 5. So that's another way you could see this answer. Okay? Once I have this much left over out of dividing this, one is this is a multiple times this is a multiple with this left over, and that would give me that. Okay? All right. I know it's tedious, so let's just do it. I'm going to do one just real clean. X squared plus 3x minus 15. I'm going to divide that by x plus 2. I'm questioning myself whether I want to show you guys synthetics side by side on this, just so that you guys can see it for tomorrow. Is it pretty good? It does. Good. Okay. So what times x makes x squared? X does. So I'm going to put it over the x column. X times 2 is 2x. X times x is x squared. Draw the line. Change the sign. This goes away. And I'm left with 3x minus 2x, which is just x, minus 15. X goes into x how many times? Or what times x makes x? I know it's 1, positive 1. So 1 times 2 is 2. And 1 times x is x. Draw the line. Change the sign. So this goes away. And I'm left with negative 17. That's my remainder. So my answer to x squared plus 3x, my answer to this, being divided by this, is equal to x plus 2 times x plus 1. That's what I got, my x plus 2. My x plus 1, those are my factors. But I have a remainder of negative 17. You don't put it in parentheses. I'm going to show you why right now, okay, with this multiplication. This is exactly why. Yes, Aaron? It's not factorable. That's why you get a remainder, because it's not factorable. It's a good question. Everything you did before last time, you were basically finding one factor, and then by the end of the week, we'll have more tools to be able to factor it all the way down. Okay? Negative 17. Exactly. But since this right here is not factorable, it's impossible. Okay? Alrighty. So the multiplication of this is I should be able to multiply x plus 2 times x plus 1 and then add negative 17, and I should get this. Right? So if I put it in a box, I have x and a 2 and x and a 1. And I get x squared and x and 2x and 2, which equals x squared plus 3x plus 2, right? But we're also going to have to now subtract 17. And I get x squared plus 3x minus 15, which is exactly what I have up there. Okay? I don't want you taking notes right this second. I want you just doing this. You guys, that's so important. I don't want you guys writing down while I'm talking. That's part of studying, is going home and you could rewrite it down. But if you're, I'm tired of arguing with people about this. If you're constantly looking up and looking down, you're not listening to everything I'm saying. You're concentrating on your writing. It's brain research. That's what it tells us right now. That's why the whole district asks us to go out and tell all the schools to do it that way. Okay? It's just you guys have been conditioned since you were little to just sit there and take notes. So it's new brain research. What was your question, Catherine? Yeah, see how I got this answer? I got these. I got this right here. There's always going to be a constant right here when you're multiplying a binomial times a binomial. You're going to get something there. So it's always going to be that and something. Sometimes it's going to be more. Sometimes maybe you'll have 2x minus 17, and you'll have to subtract the 2x from the 3x. We'll have more like that. Let's just do more. Aaron? Yes. It is not. What is the y-intercept in this problem? Negative 15. But these wouldn't necessarily be roots because of the negative 17. Nope, you can't graph based off of this. Okay. All right, so I'm going to do one that's a little bit harder. Do you guys want to try it? Well, this one's got a trinomial, so it's a little more difficult. Okay? I'm going to do it quickly. So I have x cubed minus 4x squared. But get those whiteboards out because that's where we're going next. X squared plus x. This is why it's really super important to be neat with these. Okay? Because I've got to multiply 3. I've got a ones place, a tens place, and a hundreds place. But which one is the only one I need to be concerned with when I'm trying to divide through here? The x squared. This is the one I am concerned with. That is the one I'm feeding everything else off of. Okay, so I'm going to go ahead and start. So I ask myself, what do I need to multiply by x squared to get x cubed? I need an x. Where is that x going to go? It's going to go over the 6x because that is that column, right? That is the x column. So, and when I do this, it's going to turn out really nice and pretty. So check this out. What am I going to multiply x by first? No. Ones place, tens place, hundreds place. So x times 1 is just x. X times x is x squared. I understand it's the same thing, you guys, but it's important to make sure that this goes nice and uniform. And x times x squared is x cubed. So I'm going to draw the line, change all of my signs. That should get rid of this. And I'm left with 6x minus x is 5x. 4x squared minus x squared. Sorry, I'm missing the negative, right? There's a negative there. So negative 4x squared plus negative x squared is negative 5x squared. This is a positive. And now I'm going to bring down my 8. Now I ask myself, what times x squared is going to give me negative 5x squared? Do you guys see that you should already know that it's just going to be a constant? It's just going to be a constant. It has to be because it's right over where the constants are. Say, no, it has to be. So negative 5 times 1 is negative 5. Negative 5 times x is negative 5x. And negative 5 times x squared is negative 5x squared. And I'm going to draw my line and change all of my signs. That makes this go away. And I'm left with 8 plus 5 is 13. 5x plus 5x is 10x. And that is my remainder. So this is all equal to x squared plus x plus 1 times x minus 5 with a remainder of 10x plus 13. Okay, Essence, what's your question? The negative 4x and then it's a negative. Here, this is a negative 4x squared, and a negative x squared makes negative 5x squared. No. No. The only time I change the sign is when I draw my line, right? Draw the line and change the sign. Yeah. Because that is what's driving me to know what my factor needs to be. Do you agree that we have to keep getting rid of the first term? Well, in order to get rid of the first term, I'm only concerned with this first term. Make sense? Okay, good question. Okay, so if I were to multiply this through like you have to do, I have a 3 by 2 So I have x squared and an x and a 1, and that's being multiplied by x minus 5. So x squared times x is x cubed, negative 5x squared, x squared, negative 5x, x, negative 5. So this is equal to x cubed. I have an x squared and a negative 5x squared makes negative 4x squared. I have a positive x and a negative 5x makes negative 4x minus 5. And what do I need to add to that? I need to add 10 x's. And I need to add 13. Which gives me a total of x cubed minus 4x squared plus 6x plus 7 plus 8. Is that right? Does it match this? Match this? It checks. Okay. Okay, so here's number 2. I'm going to put this up. Oh, it's going crazy on me. I'm going to put this up so you guys can check your work on number 2. But before that, can everybody put pencils down? I need to show you something about number 3. That way, for those of you that want to whiz through it, you can whiz through it. Okay, so remember we had a little bit of a conversation yesterday about place value, right? So how would you write 1,003? I'd write it 1,000 with no hundreds, Joey. No hundreds. No tens. And a 3. Isn't that 1,003? And if you don't have the place value, it's just 13, which is very different. So how could I write x cubed plus 3? You're used to seeing it like this, x cubed plus 3, but what are we missing? We're missing x squared, and we're missing x. Why don't you guys let's take a walk outside with me, please. So I have an x cubed. I have no x squared. I have no x's plus 3. Okay? So you just have to watch out for those because it's not always evident that you're missing something. So you're going to want to check it. So when I look at this problem right here and I want to set this up, it's very simple to go, oh, I'm just going to divide this by this. But I'm missing something here. I'm missing an x squared. So I would start it off as 15x cubed plus 0x squared plus 8x minus 12, all being divided by 3x squared plus 6x plus 1. So I'm going to go back to the first screen, let you guys do number 2, and then I'll come back. You guys can try this one, and then I'll do it for you. Okay? Sound good? All right, so here's this one again for you to write down. 1. Okay, so let's go now to that third one that looked messy. It's not bad as long as you have to stay organized. So 3x squared, right? 3x squared, what do I multiply 3x squared by to get 15x cubed? 5x. 5x. So where am I going to write a 5x? Above the 8x. So I have a 5x. 5x times 1 is 5x. I need to put that in the x column. So there's 5x. 5x times 6 is 30x squared. Do you guys notice I don't put signs with these? Because I'm going to change the sign anyways, right? So I never put signs with it. Then 5x times 3x squared is 15x cubed. Now I'm going to draw the line and change the sign. Change my sign. This one goes away, and I'm left with negative 30x squared, because I'm subtracting negative 30x squared from nothing, and then positive 8x minus 5x is 3x. And now I need to bring down my negative 12. Next one, 3x squared goes into negative 30x squared, negative 10 times. And I know that that's correct because it's going to be in that constant column. Negative 10 times 1 is negative 10. Negative 10 times 6 is negative 60x. And negative 10 times 3x squared is going to be negative 30x squared. I shouldn't say I don't use my signs. I don't put plus signs when it's plus because I know it's going to change anyway. Okay. So now I'm going to draw my line and change my sign. This goes away. Negative and positive 30x squared goes away. And I'm left with 63x's minus 2 is my remainder. I don't see why that one's so bad. You have to stay organized, right? Because you guys were not listening to me and putting your pencils down, right? When I said you got to put place markers. Yes. Yes. It's not too bad. Here's the check. Do it on a separate sheet of paper, like Aaron said. X cubed, sorry. 3 times 10 is negative 30x squared. 30x squared. 6x times 10 is negative 60x. 5x minus 10. So we have 15x cubed. These two cancel each other out. I have a negative 60x and a 5x, which makes negative 55x minus 10. Then I'm going to add my 63x, my remainder, and my negative 2. That's not that bad. I have negative 12. 63 and negative 55 is positive 8. X. Is that what we had originally? 15x cubed, positive 8x, negative 12. So check. It'll be on school. All of these will be on school. Tell you what, we'll just, I know it's a lot of work. How many do you have on the back to do? Not that much. 4 divisions and 4 matching. The matching is, guys, listen up. You should be able to match it without doing any work. It's just matching. You could use osmosis, right? But all you have to do is look at, I could do this in 30 seconds right now. No. Why? It's not because I'm a math teacher. Malik, what's telling you how to match them? Y-intercepts and whether it's a positive or negative graph. That's it. But you guys just, okay, so the last 4 in the back you don't have to do a check on. Yes. Number 4. You have to do checks on the front. All right, number 4. Ooh, this one's a fun one. Yes, exactly. So I have x to the 4th plus x cubed. What am I looking for? I'm looking for holes, right? There's a hole here. I'm going to need some room for this one. There we go. Okay, lots of room. X cubed plus 0x squared. tell you what, after number 4, after number 4, no more checks. How about that? 4 checks, that was a lot. Okay, 6x to the 4th plus x cubed plus 0x squared minus 9x plus 13. I'm going to break this table up over here. X squared. I have another whole, right? I have a 0x plus 8. You see it now, Jean? Done the same way, you just have another whole. So you need a place marker there. Yes. It could be negative x squared. It's 0, so it doesn't matter. Okay, I think I'm going to pause recording. All right, I'll start the first line with you guys so you can see what this looks like. What am I concerned about? I'm concerned about that coefficient right there. What do I need to multiply by to get 6x to the 4th? I need a 6. I need 6x squared, and it's going to go right above here. 6x squared. 6x squared times 8 is 48x squared. 6 times 0 is just going to be 0x cubed. And 6, this is going to be 6x to the 4th. And I'm going to draw my line and change the signs. This goes away. And I'm left with negative 48 squared. X squared, and I have an x cubed, and I subtracted nothing from it, so now I have x cubed again. It doesn't matter. I have an x cubed, I subtract nothing, so now I still have an x cubed. Okay? Then I bring down the negative 9x. So that's how you start that one off. Try the next line, and I'll do it, and then you can see how I did it. You have to ask yourself, this, right here, this times this has to make this. So what number do I have to multiply by? I have to multiply x squared by something in order to get 6x to the 4th. Because this number times this number has to make this number in order for it to go away. So what do I multiply by in order to get 6x to the 4th? I have to multiply by 6, right? And then I have to multiply by x squared. You know what I mean? Use your multiplication to find what number that has to be. What are you talking about? You're adding straight down, just like you do in division. You keep going. Now you ask yourself, x squared times what makes x cubed? Remember, that's why I'm color coding it. So I started in blue, then I bring it down, and then we start the process all over again. X times what makes x cubed? X squared times what makes x cubed? X. And you're going to know that, essence, look at, you're going to know it's just an x, not x squared or not x cubed, because look at, the next number that's going to go here is in the x column. Let me make this red. X times 8 is 8x. X times 0x is 0x squared. And x times x is x cubed. Draw the line, change all the signs. This one goes away. I have a negative 48x squared here, so I'm going to keep it negative 48x squared. And now we have a negative 17x, bring down the last number. what's this one going to be? X squared. What do I need to make it? What do I need to multiply x squared by to get negative 48x squared? Right? Come to tutoring, guys. What? No, you're always concentrating on this one. No, it's not going to be 9. No, we're not concentrating. We're not concentrating on this. We're always, like, we're shifting the problem down. So now I'm looking at x squared times what makes negative 48x squared. It's like, forget all this. This is our new problem, and we're dividing this into this. No. You're just going to have to come to tutoring lessons because I have to get ready for my next class. Thank you. I don't have the key in front of me, and I got to get ready for my next class. Yes. It would be back there. Should be in the Monday folder.